Alright, quick little revisit to the shaper, guys, to kick this episode off. I'm going to go ahead and clean up this rounded edge off the edge of this plate. You can barely see the top of the hole, and then this hole here, where this is the flat edge along the side of the crank. So I'm going to go ahead and clean that up now while I have it in the shaper, and then I'm going to go over to the bandsaw and we're going to cut this piece out. Okay guys, I'm back in action here. I got the stuff cleaned off. I blued the piece up and then relayed out. I just used the nose here as the guide, and then relayed out the small end, and still utilized this long edge that we cleaned up as one edge. So now it's time to bandsaw this out on the do-all. So let's go over there. Alright, so we're over the bandsaw. We're running about 200 surface feet a minute, I guess. We're going to start chewing this baby out. Lower this down. Alright, that's pretty good. Remember, given the choice, the saw is always the fastest way for you to remove metal. That's why we start with the saw. So we're going to clean this edge, long edge up here on the shaper. Put this thing back in the shaper and clean that long edge up. Then we're going to smooth out these other round edges by hand. Alright, we're back over in the shaper. We got our crank laid up in here, and what I did was I slipped a couple of 3/8 inch drill bits through the holes. That gives me a consistent spacing from the inside of the hole to the outside, so I can cut a straight line along here. So it shows what we got there. And my bandsaw cut's a little ragged, so I'm just going to start cutting until I get a clean cut across that surface. Okay, so we got the arm. Let me take this over here. We band-sawed it out, and I spent a little quality time with a flapper wheel and a file and kind of prettied it up. And what we're going to do now is we're going to drill for those pins. What I've done is I've got the crank nose in the spacer, got the spacer laid up here horizontally, and I've got the crank nose put in there. I put some little sacrificial shims in here. I've gone ahead and put the center finder in, and I've picked up X and Y, and I've zeroed on the top of the half by 20 hole that we've tapped here. And so what we're going to do now is we've got an offset for out to this the joint between the crank and the handle. So we're going to take the mic here and 1.282, divide that by 2, that's 0.641. So now we're going to offset, use my DRO here, which you can't see, but we're going to come over in the X, 0.641, right there, and we're going to lock the X. So we got the X and the Y locked. Kicked me out a little bit here when I tighten down the locks. Alright. I'm going to put the handle up here and see how our joint matches up. Alright. Yeah, that's right on it. So I don't really have any convenient way to lock this handle down while I'm drilling these holes. So what I'm going to do is I'm going to take my spotting drill here, this little number 7, and hopefully it doesn't chip because of this. These materials could be different. I'm going down between these two different materials. So like I said, I've never done this before. This is a first. You get to watch it, suffer through it the way I get to suffer through it. If it works, great. If it doesn't, back to the drawing board, right? So anyway, what I'm going to try to do is spot a little hole here down at least through this depth here, and then just take the drill bit, take another drill bit of that same size and drop it in that hole as a lock, and then just rotate the spacer and then start on the second hole. So, and I'm just going to hold on to this while we do it. So let's see how this here goes. Going real slow because I was worried about the drill bit kicking over into this 12L because it's softer material. But so far it appears to be working okay. So I'm going to try to get down there a little farther. Alright, that seemed to work pretty good. Let me get the other drill bit here. Okay, here we go. This is another drill bit just like this one. So what we're going to do now, I'm on 0 on my spacer. I'm going to rotate 90 degrees. I'm going to drop this pin in. And that should, yeah, that's real solid there. So that should lock us down real solid. And now we're going to go ahead and set up here with a 1/4 inch drill for the 1/4 inch pin, which is going to be the actual size that we're using. So we've spotted for the larger hole. Okay, I just started drilling this, and I can tell you right now, this ain't gonna work. Not gonna be able to drill it with this long flappy drill bit right here. Ain't gonna happen. It worked fine with this little stubby carbide drill bit, but I don't have a little stubby 1/4 inch carbide drill bit. So what we're gonna do is we're gonna swap over to a 1/4 inch end mill and a collet, and we're going to bore this out with an end mill. Alright, we got a different cutter. We're going to try it out again here. Alright, so we drilled, we milled down to the extent of the depth of cut on this mill, and then I put a 1/4 inch split pin in the hole here, rotated around 90 degrees, and now we're going to mill down again to the extent of this mill here. Now we're going to put a longer mill in, and we're going to stretch that out now that we got the hole started. What I realized was With that stubby, with that little end mill, I had broken through this section here. So I was no longer drilling through both materials. I was just drilling into this flat. So I went ahead and put a 1/4 inch drill bit in and then just opened this up down 1 inch. And that seemed to work quite well. Now I'm going to rotate this on around. And put a pin in here. Alright, we're going to drill this last hole here. Alright, those are our 2 holes, 2 pin holes. And I'm just going to put some split pins in there. Just back it on out. I am pretty sure that assembly is approaching permanent. Alright, you're starting to look like a crank here. Here's our 2 split pins. If I want to take those out, I'm going to have to run a screw in them and pull them out, because obviously I don't have a through hole all the way through. But I didn't have any dowel pins this size, so this is what I had. This is going to give us, I'm pretty sure I could put it on there just like this and use it and be just fine. But I'm going to go ahead and make the washer that's going to go around this and secure it on here with a bolt as we originally planned. And then we're going to get this thing mounted up to the machine and check it out. That'll work. As they say, good enough for government work. Let's put a big old chamfer on there, and then we're going to drill it out. drill this thing out with a slightly oversized hole just to give us a good passage there. I think this is 35/64. Slow it down a little bit. We don't have to drill all the way through. We're just going to get about ½ an inch. Alright, we got that hole in there. Let's get set up to park that off. Alright, we're going to fire it up here. Got our lube going. Go. Alright guys, here we are to finish up the KT crank handle. Obviously this could have been a whole lot less work with a little welding, right? Turn the snout, cut the handle, machine your really big chamfer on the back side here and just weld the snot out of it. You could even weld it on the front side if you wanted to, and you know, be extra secure and it'd be fine. And this project would have taken 1 video instead of 3. But I like to try out new things, and I had never done this round key setup before. Now I made the washer, which got a little video of that. Here's the washer, right? And that covers the keys and keeps them from falling out. And then I went and made a bolt. I did not video that. I was not planning on making a bolt. I thought I had a 1/2 by 20 bolt in inventory that would have done it, but this one's was too long. They were all too long. So this, my selection of hex stock was very bad, but I've made a 1/2 by 20 bolt to complete the assembly. And Snug that up. So there we go. If I had a 1/2 by 20 countersunk socketed cap screw, I would have used that and had a nice flat surface here, but I didn't. So and I'm not really equipped to make socketed cap screws. So there we go. Let's get the thread rounding device and just snug it up a little bit, and then let's go to the machine and mount it up. Alright, so we're mounted up. Something to notice here is that this split pin has to be flush with the surface or it will not slip up into the ID of the knee crank socket. Right, so it cannot protrude. So let's give her a little oh yeah. There is absolutely no slack at all in the handle. It looks really good on there. I don't even know if I'll paint it. I might just leave it bare metal. Let me pull the camera back here and get you some shots.